Hello. We'll now discuss some selected questions from the fourth chapter in +1 physics, that is motion in a plane. We'll begin with the first section in the chapter, which deals with the fundamentals of two-dimensional motion and vectors. The first question here says, the sum of the magnitudes of two vectors is 18. The magnitude of their resultant is 12. If the resultant is perpendicular to one of the vectors, then find the magnitudes of the two vectors. So we've been given three clues here, and finally we should find the magnitudes of the two vectors which is mentioned about in this question. So please imagine two vectors, p vector and q vector. We'll call them p vector and q vector, and their magnitudes will be simply p and q. Modulus of vector p will be simply p, modulus of vector q will be simply q. And their resultant r vector, which is equal to p vector plus q vector, will have a magnitude that is equal to r. You know that r is given by the expression root of p square plus q square plus 2pq cos theta, where theta is the angle between p vector and q vector. So what we are after is the magnitude or the magnitudes of these two vectors, that is p and q. We need to find the value of p and q. The first clue in the question tells us that the sum of the magnitudes of two vectors is 18. So simply we can say that p plus q is equal to 18. The first equation that we have. The second clue tells us that the magnitude of their resultant is 12. So r vector will have a magnitude that is r, which is equal to 12. So it means that root of p square plus q square plus 2pq cos theta is equal to 12. Second equation. Now the third clue tells us that the resultant of these two vectors is perpendicular to one of the vectors. So let's try and draw a figure which matches the situation. We have vector p here and we have our vector q here. And if I try to find the resultant here in terms of the parallelogram law, I'll complete the parallelogram here and I'll draw the diagonal, which would give me the resultant, and this here will be r vector, and the question tells us that r vector is perpendicular to p vector. The angle between q vector and p vector is theta, and I'll call this angle the angle between the resultant and p vector alpha. Alpha, you know, is 90 degrees according to the question. The question tells us that the resultant is perpendicular to either vector, so I'll choose p vector to be that vector which is perpendicular to the resultant. Now, from this figure, you know the expression to calculate tan alpha, and tan alpha will be equal to q sine theta divided by p plus q cos theta. That is an expression that we've already studied. And now alpha is 90 degrees, so you know that finally tan 90 has to be equal to q sine theta divided by p plus q cos theta. So tan 90, you know, is infinity. So if the left hand side has to be infinity, the denominator of the right hand side will have to be 0. That is purely mathematical. Now, so I can say that p plus q cos theta is equal to 0, and this is what we get from the third clue. That's the third equation. And what we'll now do is we'll use all these equations and we'll write down a single equation combining all these and solve that equation to find the value of one of these vectors, the magnitudes of one of these vectors, and we'll find the other one easily with the help of these equations. So we'll choose the second one to be our main equation, and we would replace the value of q square and q cos theta based on the equations 1 and 3. I'll explain how. You know that p plus q is 18, so you can say that q is 18 minus p, which means that q square will have to be 18 minus p square. So I can replace q square from this equation in terms of p. Now, q cos theta can be easily written from this expression here. P plus q cos theta is 0, so you can say that from this expression, q cos theta is minus p. I'll write that down here. Q cos theta is minus p. Now, if I replace these two terms here from this equation, I can get this equation exclusively to be in terms of p. And that becomes an equation in single variable, and you can easily solve it. So when I try and replace all these terms, I'll have root of p square plus, instead of q square, I'll have 18 minus p whole square, and then plus 2 into p, I'll keep that intact, and then I have q cos theta, which can be replaced with minus p, and this will be equal to 12. You can look at this equation and understand that it is purely in one single variable, and you can easily solve it. I'll start by squaring both sides and expanding the terms. So I'll have p square plus 18 minus p whole square plus, or it could be minus 2p square, because you have a minus p to be multiplied along with 2p here. That will be equal to 12 square, that is 144. Now if I further expand this, I'll have p square plus 18 square is 324 minus 2 into 18 into p, that is 36p plus p square. And that is how we expand a minus b whole square. A square minus 2ab plus b square. And then you have minus 2p square, that term as well here. That will be equal to 144. Now, p square minus 2p square gets cancelled off, and then you have, if I rearrange it, 36p will be equal to 324 minus 144. Now that is 36p is equal to 180, which means p is equal to 180 divided by 36, which is equal to 5. Now, we know that p now is 5. And from the first equation, we know that p plus q is 18. So if p is 5, q has to be 13. So we can say that p is equal to 5 and q is equal to 13 is our final answer. That is how we solve it. We have written down 3 equations based on the clues that were given in the question, and then we finally simplified them. That is how we solve this question.